Unit V. Explore conversational AI. Introduction. Anomaly detection is an artificial intelligence technique used to determine whether values in a series are within expected parameters. There are many scenarios where anomaly detection is helpful. For example, a smart HVAC system might use anomaly detection to monitor temperatures in a building and raise an alert if the temperature goes above or below the expected value for a given period of time. Other scenarios include monitoring blood pressure, evaluating mean time between failures for hardware products, comparing month-over-month expenses for product costs. The Azure Anomaly Detector service is a cloud-based service that helps you monitor and detect abnormalities in your historical time series and real-time data. Learning objectives. After completing this module, you'll be able to black circle describe what anomaly detection is. Black circle describe how the Anomaly Detector service can evaluate time series data. Define scenarios where anomaly detection can be applied for real-time and historical. What is anomaly detector? Anomalies are values that are outside the expected values or range of values. In the graphic depicting the time series data, there is a light shaded area that indicates the boundary or sensitivity range. The solid blue line is used to indicate the measured values. When a measured value is outside of the shaded boundary, an orange dot is used to indicate the value is considered an anomaly. The sensitivity boundary is a parameter that you can specify when calling the service. It allows you to adjust that boundary settings to tweak the results. Anomaly detection is considered the act of identifying events or observations that differ in a significant way from the rest of the data being evaluated. Accurate anomaly detection leads to prompt troubleshooting, which helps to avoid revenue loss and maintain brand reputation. Azure's Anomaly Detector service. Anomaly Detector is a part of the Decision Services category within Azure Cognitive Services. It is a cloud-based service that enables you to monitor time series data and to detect anomalies in that data. It does not require you to know machine learning. You can use the REST API to integrate Anomaly Detector into your applications with relative ease. The service uses the concept of a one-parameter strategy. The main parameter you need to customize is sensitivity, which is from 1 to 99 to adjust the outcome to fit the scenario. The service can detect anomalies in historical time series data and also in real-time data such as streaming input from IoT devices, sensors, or other streaming input sources. How Anomaly Detector works. The Anomaly Detector service identifies anomalies that exist outside the scope of a boundary. The boundary is set using a sensitivity value. By default, the upper and lower boundaries for anomaly detection are calculated using concepts known as expected value, upper margin, and lower margin. The upper and lower boundaries are calculated using these three values. If a value exceeds either boundary, it will be identified as an anomaly. You can adjust the boundaries by applying a margin scale to the upper and lower margins as demonstrated by the following formula. Upper boundary equals expected value plus 100 margin scale. Upper margin. Data format. The Anomaly Detector service accepts data in JSON format. You can use any numerical data that you have recorded over time. The key aspects of the data being sent includes the granularity, a timestamp, and a value that was recorded for that timestamp. An example of a JSON object that you might send to the API is shown in this code sample. The granularity is set as hourly and is used to represent temperatures in degrees Celsius that were recorded at the timestamps indicated. Granularity. The service will support a maximum of 8,640 data points. However, sending this many data points in the same JSON object can result in latency for the response. You can improve the response by breaking your data points into smaller chunks, windows, and sending these in a sequence. The same JSON object format is used in a streaming scenario. The main difference is that you will send a single value in each request. The streaming detection method will compare the current value being sent and the previous value sent. Data consistency recommendations. If your data may have missing values in the sequence, consider the following recommendations. Sampling occurs every few minutes and has less than 10% of the expected number of points missing. In this case, the impact should be negligible on the detection results. If you have more than 10% missing, there are options to help fill the dataset. Consider using a linear interpolation method to fill in the missing values and complete the dataset. This will fill gaps with evenly distributed values. The anomaly detector service will provide the best results if your time series data is evenly distributed. If the data is more randomly distributed, you can use an aggregation method to create a more even distribution dataset. When to use anomaly detector. The anomaly detector service supports batch processing of time series data and last point anomaly detection for real-time data. Batch detection. Batch detection involves applying the algorithm to an entire data series at one time. The concept of time series data involves evaluation of a data set as a batch. Use your time series to detect any anomalies that might exist throughout your data. This operation generates a model using your entire time series data, with each point analyzed using the same model. Batch detection is best used when your data contains black circle flat trend time series data with occasional spikes or dips. Seasonal time series data with occasional anomalies idiographic period. Seasonality is considered to be a pattern in your data that occurs at regular intervals. Examples would be hourly, daily, or monthly patterns. Using seasonal data and specifying a period for that pattern can help to reduce the latency in detection. When using the batch detection mode, Anomaly Detector creates a single statistical model based on the entire data set that you pass to the service. From this model, each data point in the data set is evaluated and anomalies are identified. Batch detection example. Consider a pharmaceutical company that stores medications in storage facilities where the temperature in the facilities needs to remain within a specific range. To evaluate whether the medication remains stored in a safe temperature range in the past 3 months, we need to know: black circle the maximum allowable temperature, the minimum allowable temperature. Black circle the acceptable duration of time for temperatures to be outside the safe range. If you are interested in evaluating compliance over historical readings, you can extract the required time series data, package it into a JSON object, and send it to the anomaly detector service for evaluation. You will then have a historical view of the temperature readings over time. Real-time detection. Real-time detection uses streaming data by comparing previously seen data points to the last data point to determine if your latest one is an anomaly. This operation generates a model using the data points you send, and determines if the target current point is an anomaly. By calling the service with each new data point you generate, you can monitor your data as it's created. Real-time detection example. Consider a scenario in the carbonated beverage industry where real-time anomaly detection may be useful. The carbon dioxide added to soft drinks during the bottling or canning process needs to stay in a specific temperature range. Bottling systems use a device known as a carbo cooler to achieve the refrigeration of the product for this process. If the temperature goes too low, the product will freeze in the carbo cooler. If the temperature is too warm, the carbon dioxide will not adhere properly. Either situation results in a product batch that cannot be sold to customers. This carbonated beverage scenario is an example of where you could use streaming detection for real-time decision-making. It could be tied into an application that controls the bottling line equipment. You may use it to feed displays that depict the system temperatures for the quality control station. A service technician may also use it to identify equipment failure potential and servicing needs. You can use the anomaly detector service to create a monitoring application configured with the above criteria to perform real-time temperature monitoring. You can perform anomaly detection using both streaming and batch detection techniques. Streaming detection is most useful for monitoring critical storage requirements that must be acted on immediately. Sensors will monitor the temperature inside the compartment and send these readings to your application or an event hub on Azure. Anomaly detector will evaluate the streaming data points and determine if a point is an anomaly. Exercise. Explore cognitive services. In this exercise, you'll test the capabilities of the anomaly detection service. You'll use a simple command line application that runs in the Cloud Shell. The same principles and functionality apply in real-world solutions, such as websites or phone apps. 1. What is meant by seasonal data? See data based on the time or year it was recorded. See how far apart the values are by default for each recorded period. Data occurring at regular intervals. Correct. Seasonal time series is considered to be a pattern in your data that occurs at regular intervals. Examples would be hourly, daily, or monthly patterns. 2. What is the purpose of specifying granularity in your JSON data object? It is used to indicate the recording pattern of the data. Correct. Granularity would be specified as hourly, daily, weekly, etc. C. It tells the service how to chunk up the results that are returned for review, independent of the time series data pattern. C. It is used to indicate the range of acceptable values. 3. How does the anomaly detector service evaluate real-time data for anomalies? C. It collects all the values in a window of time and evaluates them all at once. It evaluates the current value against the previous value. Correct. It evaluates previously seen data points to determine if your latest one is an anomaly. C. It uses interpolation based on the current value and the previous value to predict what the expected value should be. Summary. The anomaly detector detects anomalies automatically in time series data. It supports two basic detection models. One is for detecting a batch of data with a model trained by the time series sent to the service. The other is used for detecting the last point with the model trained by points before. Packaging your time series data into a JSON object and passing it to the API. Anomalies can be detected in the time series data. Using the returned results can help you identify issues with industrial processes or recorded events. Batch series data is best used to evaluate recorded events that represent seasonal patterns and don't require immediate action. Streaming data points into the API can offer real-time awareness of anomalies that may require immediate action. The API can be integrated into your applications by using REST calls or by incorporating the appropriate SDK into your code. Using the anomaly detector service does not require you to devise or to be knowledgeable in machine learning algorithms.